Hey, good morning, you guys. I wanted to see if I could help you out with the next two climate variables. Your assignment is to do climate variables number 3 and number 4, and we'll just tackle this first one, albedo, right now. And so, what albedo is basically the ability of sunlight to be reflected off of a surface. And you can imagine a white sidewalk in the summer versus blacktop in the summer. You know, the blacktop is going to be a lot warmer than the white sidewalk. That's because the light bounces off the white sidewalk. Well, the same is true for sea ice. And this diagram shows how much how much sunlight actually gets to the ground. It's only about 49%, because the rest of it is getting reflected back up into space. So this first question is pretty easy. I'll leave that one. Um, the second question is a little bit trickier, and this graph is pretty tricky. And one thing I want to note is that this part right here. This is over the last 60 years. So, as it turns out, um, volcanoes throw stuff up into the air and that blocks sunlight. So, sunlight hits those particles and it bounces back up into the atmosphere and never hits the ground. So, this graph is we're looking at overall what's happening with global temperature. That's the x axis here. That's global temperature. And then this is the last 60 years. So I'm going to put a 60 years on the bottom here. So this is now, this was 60 years ago, in 1960. So what's happening to the temperature? Well, the temperature definitely has, I'll just do a dotted line. The trend of the temperature is definitely up, as we saw in number 4 up above, right? In the first climate variable, we saw the temperatures increasing, especially since 1975. If we go back to this, so we see the temperatures increasing. The question is, are volcanoes contributing to this long-term temperature increase? And I think what I'm seeing, tell me if you see. Let's see. I'll use red. Um, it looks like, well, right here, there's an increase, but then it decreases again and it increases again. So I don't know if that really leads to the long-term trend. And here, after this eruption here, well, the temperature goes up, but then it goes down again. And then on this one right here, well, the temperature actually dropped a little bit. So I don't think that the volcanoes are the cause of this overall long-term trend upwards of temperature. What do you think, though? Take a look at the data and tell me what you think. Um, Now, this one's a little bit trickier too. What we're talking about here is sea ice extent. And as you know, the polar ice caps have a lot of snow, and that would reflect a lot of sunlight. So, what would happen if we had more sea ice? And you're right, we would have more light reflected back up into the atmosphere. But if some of that ice goes away, more sunlight's going to get absorbed. Catch my drift here? This graph is kind of interesting. So again, we have, I'll use yellow here. So we have the Antarctic, which is South Pole here, and we have the Arctic up here in the red line. And what I'm seeing is the sea ice extent. The trend of this is generally down. So the sea ice in the North Pole area is going down, whereas in Antarctica it's holding pretty steady. And as it turns out, we have now that it's actually decreasing a little bit. Um, so that's kind of interesting. So if you have less sea ice, what does that mean for sunlight getting absorbed by the ground? It's going to go up, right? So the less sea ice you have, the more sunlight you have hitting the ground, the more warming there is, and the less time or the less ice you have. This is about to end, so I'm going to do another one to do question 4. Okay?